Alright guys, here we go. I'm going to do a couple of them for you. Alright, so we'll start with number 5 since it's pretty basic. It says, I'm not going to show you my paper because it has the answers. So, alright, so these are the equations you need to know. Alright, C, which is the speed of light, equals frequency times wavelength. Alright, V, or this Greek letter V, is frequency, and then I think that's nu is wavelength, alright? And then C equals 3, and I use scientific notation. That works for me. Whatever works for you. I think that's, what is that? That's 3 with 8 zeros of 1, 2, 3, 4, 5, 6, 7, 8. It's a 300 million meters per second, right? And yes, I use meters per second because, you know, it's science. Alright, so it says calculate the frequency. So you're looking for frequency is your unknown, alright, equals question mark. Calculate the frequency of ultraviolet blue light, which has a wavelength, so there's that, equals 350 nanometers. Now, in your book, yes, in your book, in the very back of chapter 1, there's a table, and that tells you all the prefixes and suffixes for all this kind of crap. So if you look, nanometer, a nanometer is equal to 1 nanometer is equal to 1 times 10 to the negative 9 meters. So, crap, I forgot to even calculate. Give me a second. Alright, sorry, I forgot to get my calculator out and ready. Yep, I'm unprepared, as usual. So, easiest way to do this, 350, go to your calculator, okay? 350 times, alright, 1, and yes, there is a thing for the scientific notation, alright? It's right here, it's the E button, alright? So 1 second E to the negative 9. Alright, that's 350 times 1 times 10 to the negative 9, and this will give you the answer in meters, which is what you're looking for. It has to be in meters, alright, because this is in meters, alright, and I'll get to that, the reason for that in a second. Alright, so 350 times 1 times 10 to the negative 9 equals 3.5 times 10 to the negative 7 meters, alright, so we know C equals the unknown times 3.5 times 10 to the negative 7 meters. Okay? So, we know what C is. So, we're going to go over here and we're going to rewrite this as 3.0 times 10 to the 8 meters per second equals, I'm trying to write this while I'm looking through the camera, so I'm sorry if it gets all kinds of messed up. So, alright, equals frequency times 3.5 times 10 to the negative 7 meters. Alright, so if you do everything right, you're going to get, to make sure the equation equals out, since we're looking for seconds, it's cycles per second, so you want your end result wants to be seconds, and this is why one of the reasons why you need to convert this nanometers to meters. All right, this is going to kind of help you out. What you're looking for, frequency, is cycles per second. That's the big key right there, second. All right, so we need to get out of this, we need to get seconds. So you know that you're going to have to divide this into this. So you're going to rewrite it again. 3, oh, sorry, help if I get it over here. 0.0 times 10 to the 8 meters per second divided by 3.5 times 10 to the negative 7 meters equals your frequency. Alright? Now, this is why converting it to meters becomes important, because since we have meters per second divided by meters, you can cross out the meters, and that will leave you with seconds. So your end answer is going to be in seconds. Alright? So now you go over here to calculator, handy dandy calculator. You 3 times 10 to the 8 divided by 3.5 times 10 to the negative 7 equals 8.57 times 10 to the 14. Alright? So V, your frequency, equals 8.57 times 10 to the 14 cycles per second, or hertz. All right, they're both the same thing. So there's your answer. All right. All right, let's do another one. This is gonna be kind of a long video, so next one is kind of I'm gonna do the next one, and then we'll do number 9. The reason why I'm gonna do this one is because a reason. All right. So this one, same thing. All right, calculate the frequency of a 1. So you're looking for the frequency. Your frequency is the unknown variable. Calculate the frequency of a 1.77 angstrom X-ray photon. All right, so your wavelength equals 1.77 angstroms. Now, in your book, once again, you kind of have to read to find it, unless you already know it. An angstrom, 1 angstrom equals 1 times 10 to the negative 10 meters. All right, so you want, like, once again, you want to convert it to meters. All right, so it's 1.77 times 1 times 10 to the negative 10, and that gives you 1.77 times 10 to the negative 10. Very simple. So C equals frequency times 1.77 times 10 to the negative 10 meters. Alright, and once again we rewrite it for speed of light, so it's 3.8 times 10, 3.0, I'm sorry, 3.0 times 10 to the 8 meters per second equals frequency times 1.77 times 10 to the negative 10 meters. Rewrite it again. Alright, we're going to come down here. 3.0 times 10 to the 8 meters per second over 1.77 times 10 to the negative 10 meters equals frequency. Cancel out your meters, left with your second, you know you're good. Go around it in a calculator. 3 times 10 to the 8 divided by, and we're going to do this simple way, the answer equals 1.69 times 10 to the 18 hertz. Yeah, I screwed up on my crap last night. Anyways, so yeah, your frequency equals 1.69 times 10 to the 18 hertz. And there's your answer. Alright? Oh, okay, sorry, my phone was ringing and a message came up, so. Alright, next one we're going to do, and this is going to be the last one, I'm going to do number 9, because this is where everybody starts to get really weirded out about it. It's the same thing, all the information is given in your book, you just got to look for it and write it down, so it's all formulas. So, it says calculate the energy in kiloelectron volts, so you're looking for the energy in kiloelectron volts of an X-ray photon that has a frequency of 1.69, so your frequency equals 1.69 times 10 to the 19 hertz. Alright? Or cycles per second, whatever you feel like putting down. Now, the formula for this equation is the one that she put on the board. It was kind of the last one. It was on the PowerPoint. E equals H times frequency. H is your Planck's constant, equals 4.15 times 10 to the negative 15 electron volts seconds. Alright? Everybody see that? Good. Alright. So now, once again, you're just plugging the information into your equation. Alright? So you have E equals, E is the variable that you're looking for. E equals 4.15 times 10 to the negative 15 electron volts seconds times 1.69 times 10 to the 19 hertz. Alright, so there's your equation. You're looking for the energy. So now you come over here to handy dandy calculator. Once again, 4.15 times 10 to the negative 15 times 1.69 times 10 to the 19. And that gives you 7.0135 times 10 to the 4 electron volts, because that's what it's going to be in, alright? 7.01 is what we're going to round it to, times 10 to the 4 electron volts, but we're looking for kiloelectron volts. So, divide all this by 1,000, because 1,000 kilos equals 1. So come over here and just hit divided by 1,000, and that gives you 7.01 times 10 to the 1, or let's see here, equals 7.01 times 10 to the 1 kilo electron volts, or if you don't feel like writing all that nonsense out, 7D.1 kilo electron volts. Alright, it's all formulas. Once you figure out which formula you need, if you're looking for energy, you're going to use one of the Planck's formulas. Alright, if you're looking for frequency or wavelength, and you are given one or the other of frequency or wavelength, you're going to use this formula, because speed of light is always a constant. If you're given frequency and you're looking for energy, you're going to use this formula, because the Planck's constant is always a constant. So you just need to find out which formula you need to use, figure out what equation you're going to use, find the information that's given, find out what information you need, and plug it all in. Alright? So here's your three answers. This is number 5, number 6, and this one is number 9. Alright? Y'all got any questions? Let me know.